Okay, I'm going to introduce you to the idea of a vector. You've just looked at 3D coordinates, so we're going to understand what a vector is, to be able to use vector notation, interpret 2D vector diagrams, and then sketch 2D vectors given their components. So I do usually show you a wee video from Despicable Me. If you want, go on YouTube. Despicable Me vector, and you basically just get the villain in the main film telling you about what a vector is. But I'll do the boring part. So a scalar is a quantity that tells us about size or magnitude, so only tells us the information about how big it is. A vector does the same thing, but it tells you about direction. So for example, I could take a few steps towards the camera, 1, 2 steps towards the camera. That is a scalar, because I've not told you the direction. If I come back and I say, do you know what, I am going to, so if we pretend that the board's north, I am going to walk 2 steps to the south, 1, 2, that's me now showing you as a vector. So, let's move page. Okay, some examples. Scalar, distance, driving a car. The vector equivalent would be driving a car in a direction. Mass, this is the one that people get confused with. Weight is not a scalar, it is a vector. So your mass is 80 kilograms, that's what we say we weigh, but the weight is also a vector because it's the mass, but the direction is gravity because you're pushing down, and then speed and velocity, kind of a common example. So, right, we're going to work with vectors in 2D and 3D. A vector basically tells you how to get from a start point to an end point. So in this one here, what we tend to use is something called a directed line segment. It's basically a line with an arrow on it, so hopefully you can see that arrow there. The diagram basically tells us how to get from point A to point B, and the notation is AB with an arrow on it. Tells you how to start from A and get to B. Okay, so vectors work very similar to coordinates. We've got an X component, a Y component, then we're going to look at Z components. Funnily enough, it's called component form. So what I'm going to do is I'm going to just look at the first vector, and I'm going to just basically draw in a wee triangle, and I'm going to go 1, 2, 3, 4, 5, that's 6. 1, 2, 3, 4. So the vector AB is 6, 4. Likewise, if I go to this one here, I'm going along 4, but then down 5. So RS is 4. But if you think of coordinates, if this was 0, going down makes it negative. And likewise with this one here, I'm going to go along, or back should I say. Sorry about the dodgy, oops, I'm going to redraw that. So, drawing the X, what have I done? 1, 2, 3, 4, 5, 6, 7, 8, 9. So, P to Q is negative 9, because if I go to the left it's negative. The reason I've done that is because the arrow's telling me to go left first, then I'm down by 2, so it's down 9, negative 9, negative 2. If you're asked to draw them, which will come in a wee second, it's the same idea. But if you want to go to this exercise, pause it, and I'm going to just tell you the answers. So AB is the vector 2, 6. CD is the vector 1, negative 6. EF, going back 2, up 5, so it's negative 2, 5. G to H is back 1, 2, 3, 4 and down 2, so negative 4, negative 2. Let me move the board. IJ, well, I'm going forward 3, but I'm not moving up or down, so it's 3, 0. And then I'll squeeze KL here, and that is not going to cross anyway, so it's 0, but it is coming down by 4, so it's 0, negative 4. Okay. Sketching each of the vectors. I'm only going to do a select couple here, so I'll do A. So I'm going to pick a point, so I'm going to start here, and I'm going to go along 2. So what I'll do is I'll do it in highlighter because the dotted line's not great. So I'm going to go along 2, and then up 5. What I am going to do in pen, I'll go black, I'm going to join that start point to the end point, and then put an arrow on it. So that's A and B. So I've went along 2, and I've went up 5. What else will I do? I'll go for C. So I'm going to start here, I'm going to go along 3, and then I'm going to go down 4. Again, follow the arrow, it's going to go down the way, because I went along, always go along, then down, or along, then up. So that is E to F. We'll go for IJ. So IJ is going to be -2, 5. So I'm going to start here, but I'm going back 2, then up 5. So the line's going to go like that. I and J. And then the last one, we've got -4, -1. I'll do that down the bottom. So -4, back 4, down 1, it's a really small vector. And that is going M to N. Okay. To add and subtract vectors in 2D and 3D. So we're going to use that idea of the initial stuff about vectors to get right into it. Okay, to add or subtract vectors, we add or subtract the components, and that gives us what's called the resultant vector. The past paper tends to mention that buzzword of resultant vector. So first thing I'm going to do is basically extract the info. Well, that vector there, A, what's that? 1, 3. B, 4, 2. So if I want A plus B, I'm going to basically add these two together. Add the x's, add the y's. So what have I got? 1 add 4 is 5, 3 add 2 is also 5. So the vector I'm going to draw is going to go along 5, then up 5. So blank canvas. Here's my point A. So what did I say? Along 5, up 5 to point B. And again, draw your line with the arrow on. If you don't put that arrow on, you don't get the mark. So there is your vector, and you can write it down if you want. AB is 5, 5. Okay, next one. A minus B. Okay, so again, same vectors. What do we have? A was 1, 3. B was 4, 2. So A minus B is going to be 1 take away 4 is -3. 3 take away 2 is 1. So I'm going to draw a vector that goes back 3, then up 1. So back 3, any position here, back 3, up 1. So it's quite a small vector. So this is going to be A minus B. And I'm just going to call that A and B for help. And that was -3, 1. Okay. We'll look at one like this, then we'll get into the past paper. Ones with 3D. Okay, again, A equals 1, 3, B equals 4, 2. What have I got? 2A plus 3B. Well, let's write down what 2A is. Double that, it's going to be 2, 6. That's going to be 12, 6. So that's going to be 14, 12. Quite a big vector. Okay, on to this page. Now I'm going to start down the bottom. I'm going to go along 12. Get a feeling that I might need to use the whole bit here. So if I go, oops, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Then up 12, 3, 6, 9, 12. Okay, and then I'll just use the straight line tool for this one because there's not a chance I'm going to get that accurate. So there we go. And again, most important thing is that arrow. So that is A, 2A plus 3b. And it was 14, 12. Okay, so on to a past paper question, very similar. If you want to pause and have a wee go. Okay, so P was minus 5, 3. Q is 4, negative 5. So P plus Q is negative 1, negative 2. Okay, in 3D, believe it or not, actually probably easier. Oh, here's another 2D one first. Okay, first question 2016, find the resultant vector a half of P plus Q, right? A half of P plus Q, this time we don't need to draw it. Well, what's a half of P? 2, negative 3, plus negative 5, negative 1, and in component form is that kind of column, so that is minus 3, minus 4. You get 1 mark there, you get a second mark there. Okay, next one. 2014, 2u minus v. Okay, same idea, 2u minus v. What's 2u? It is going to basically double all of these, so it's minus 4, 6, and 10. Take away v, 0, minus 4, and 7. That is minus 4. 6 take away minus 4 is 10. 10 take away 7 is 3. And again, you get 1 mark there and 1 mark there. Okay, couple to go. I want you to give them a go, and if you pause, I'll tell you what the answer should be. So the vector answer for this one is going to be 4, 3, minus 5, and this one here, well, 3a plus 2b, 3a is going to be 6, 12, 15, 2b is going to be minus 8, 4, 0, and that comes out as minus 2, 16, 15. And finally, from 2018, two vectors are given by u equals 1, 5, 1, and the answer, u plus v equals 6, negative 4, 3, find v. Two ways to go about doing it. Personally, I would say u plus v is 6, negative 4, 3. So what was u? Well, u was 1, 5, 1, and compare, well, v must be 1 add something 6, it must be 5. 5 add something's negative 4, you're going to take 9 off, and 1 add 2 gives you 3. Alternatively, what you could do is, I'll do it in a different colour just here, you could have done 6, negative 4, 3, take away 1, 5, 1, and that would give you exactly the same answer. So, okay.